Well, thank you all. It's my pleasure to describe and announce the first Niebur Award winner for today. Just a few words about Susan Niebur, for those of you who did not know her. She was a former NASA program scientist and founder of the Women in Planetary Science project. She was known for her entire career to support students at every level with personal and professional development, and established the first ever early career fellowships and workshops for planetary science program while at NASA headquarters. And I always prefer to borrow words from others, and I feel this quote from the DPS sums up Susan better than I ever could. And I quote, "She will be remembered for her untiring work to bring people together and to find ways to help everyone to be able to live up to their potential. For the passion and incredible energy she brought to everything she did, for the encouragement and inspiration she provided to others, and for her wonderful and unfailing smile." And I can say with certainty that our first and second, of course, Niebur Award winners for 2017 embodies the attitude and outlook on life for which Susan Niebur is so well known. And so it is my pleasure to announce Dr. Adrienne Dove as the Susan Mahan Niebur Early Career Award winner. You can keep coming up. It's people can look at you as I, give you accolades. So Addie received her BS degree from University of Missouri Columbia and her master's and PhD from the University of Colorado Boulder in 2009-2012 timeframe. And she was a postdoctoral research fellow at the University of Central Florida, where they loved her so much and decided they couldn't live without her, so they made her an assistant professor in 2015. Her previous work is quite varied, from modeling mass energy balance of terrestrial snowpack to the lunar photoelectron environment and dust dynamics. And most recently, her work has focused on low-speed impacts and microgravity, and she's the PI of the Strata experiment and payload, which is flown on the ISS. Additionally, she is the principal investigator on SURFSAT, a CubeSat that looks at plasma-induced surface charging and electrostatic discharge. And she is also a co-investigator for multiple other ISS payloads, CubeSats, and suborbital experiments, including the Hermes, QPACE, Prime 4.0, et cetera, et cetera, et cetera, et cetera. So I can obviously go on and on about her scientific accomplishments, but her commitment to the lunar and small body community development deserves equal, if not more, recognition. She was integral to starting the Loon Grad Con, I think actually the founder of Loon Grad Con, if I recall correctly, which is a graduate student-led conference focusing on the moon and small bodies. She has served on a myriad of science organizing committees for many top conferences and the principal organizer of annual Observe the Moon Night. Addie's communication skills are, quote, out of this world. That's my quote. And she's used those skills as a co-host of the astronomy podcast, Walk About the Galaxy, which I think is published a couple times a month. Is that right? A couple times a month. And she speaks to children's classes, gives endless public lectures, and I guess endless is more about the number rather than the length of them, and is a strong advocate for STEM education and women in science. And perhaps most importantly, she makes some wicked good cupcakes, cookies, and home brew. So, yeah, absolutely. The last award that I wanted to mention is one, and I quote, she is one of the 31 wonderful women who have been instrumental in shaping UCF's past, present, and future. And those of us who have been lucky enough to have gotten to know Addie personally, and to be honest, I'd be surprised if there's anybody in this room that doesn't know Addie, we have all witnessed her boundless energy, her quick wit, and welcoming personality. And so we are honored to present this award to a wonderful scientist and a truly wonderful woman, Dr. Addie Dove.
Well, thank you, Brad. I just wanted to do a quick correction. I wasn't the PI on Strata. I was a co-I and built most of the hardware, but I am the PI on Strata suborbital version. So I didn't want to take credit from Paul or Mark or whoever else might be here. Okay, so first of all, I want to say that I'm honored to receive this award. I met Susan a few times early on in my career when I was a graduate student. attending some of the Women in Planetary Science networking events that she started and that have continued and grown and spread throughout many of the different conferences we attend since then. And she was an amazing scientist. She was incredibly dedicated to both science and exploration, but she was also, as it's been mentioned, dedicated to mentoring and really developing a community of scientists. And so today I'm going to talk a little bit about those three things: science, exploration, and community. I'm not going to talk at length about science, because that's what the rest of this conference is for. I think there's going to be a lot of that. I am giving a talk later in the week. But I do want to talk a little bit about sort of my development of my science and exploration potential here through SSERVI and through what was formerly NLSI, and the development of the community that I've really come to know and respect and love here. A lot of the people here in this room and who aren't here in this room that are part of this lunar science and asteroid science and surface science community. So I'm not going to go to my first slide quite yet. Brad mentioned I've worked on a variety of scientific topics throughout my grad school, postdoc, and early professor career. I started actually with Jen Heldman, who I think was here in the room earlier. I had a GSRP with her when I was in grad school, and we were studying snowpacks on Mars. We were studying snowpacks here on Earth, but how they applied to energy balance and snowpacks on Mars. And then I actually worked with Jack Burns, who I give all my credit for all my success to, who is here in the room also. I worked with him for a summer looking at mapping of deployment of radio arrays on the lunar surface. And since then, and then after that, I worked with Mihai Horanyi, who's also here in the audience. He was my PhD advisor. And I've worked with all of these amazing people who have given me every chance to succeed and who have also really let me be both a scientist and, as Brad mentioned, someone who is involved in the community and who tries to communicate science and all of the amazing work that we do with the next generation, with students, and also with the public. And then, obviously, I can't forget to mention Dan Britt, who is here also, and he's the PI of the class node, of the SSERVI class node, and I'm working with him at UCF in that capacity. Okay, so really quick description of some of the science that I'm working on right now, just because I like showing some fun pictures of what we're working on right now. So the next slide. Generally, my career these days is driven by understanding dust dynamics and plasma interactions with dusty surfaces in space. So that can apply to the moon, to asteroids, to places like Saturn's rings and planet formation. It's a wide variety of environments that all have similar processes taking place. And so most of my work is experimental work, trying to understand how we can characterize those environments and how we get to the basic science of understanding the processes at work there. So these are just a few awesome pictures of the lunar surface of Eros, and Saturn's rings, where you see amazing structure in the rings that is actually due to dust building up at the edges of rings. And you can see the shadows there cast by the sunlight hitting the edges of those rings. Next slide is, there's a couple of videos on the left. Oh, I don't know if oh, there it goes. It's just slow. It's supposed to be slow. So these are a couple videos of experiments that I've been involved in that look at impacts in microgravity. So these are impacts that happen at very, very low velocities, so centimeters per second. Speeds where we have a marble impacting a surface and we want to understand how it rebounds off the surface, what kind of ejecta you get. And we do this in microgravity environments because these very slow speeds, A, you can't do them on Earth, and B, that's what the environments on the moon, asteroids, and things like that are actually like. So you can see here the one in the center that keeps bouncing, that's a marble bouncing off a JSC lunar simulant. I know Larry Taylor, it's not his favorite simulant, but it's the one we use for a lot of things. And so you can see there we have it bouncing off the surface. This is a really low speed in a parabolic airplane flight. So that's actually happening in the box that you see floating here in the airplane. My hair was much longer then. It made much more exciting effects on the plane, I think. And And on the left, that's actually an experiment we do in a drop tower at our labs at the University of Central Florida, where we can reproduce, again, these low-speed impacts into different regolith simulants in a very short duration microgravity environment. So I think the next slide, oh yeah, I'll come back to that in a second. So my next slide is just a number of other projects. And one of the key things about all of these projects, and that you've heard everyone else who's spoken up here mention, is that they're all done as part of teams. So the two sort of CAD drawings, the two drawings are of CubeSats that we're working on right now that are both to understand planet formation and asteroid surface processes, and then also a satellite to understand charging on spacecraft that are orbiting the Earth, or with extension that will go to the moon or to other planets, to asteroids. And then this picture here on the far left or far right for all of you, is actually a picture of Strata, which is the experiment that has flown on the International Space Station for about a year. It just came back like a month ago, and it just came back to the ground and is at JSC in Houston yesterday. So we just got this payload back. But this experiment was actually trying to understand regolith sorting in microgravity. So looking at if you have layers of regolith and you put them up on the space station where there's this interesting vibrational and microgravity environment, what kind of regolith sorting do you get? What sorts of size distributions do you get, and how does it move around in that microgravity environment? We're hoping for lots of follow-up studies on that experiment, but it's really exciting, and we're in the process of analyzing the data right now. The other little box sort of in the middle is another experiment that flew on the International Space Station for about a year. It was called NanoRocks. So we flew it with the NanoRacks company, and it's a little tiny payload. It's a 1.5U, which is about this size for scale. Payload that was looking at little collisions between particles. So you see all those little trays have different particles. We looked at collisions between all of those little particles in the trays to understand planet formation and different processes that happen when you have particles colliding again, at very low speeds. And that's the one on the left is a vacuum chamber. I can't not show a vacuum chamber in one of my talks because I love them. That's the holodeck, in case you're wondering. All right, so next slide, though, really gets to a lot of what I want to talk mostly about today, which is the fact that none of us could do the science we do without the community around us. People who are more advanced in the field rely on their students, their postdocs, to accomplish most of the science that gets done. Everyone here has gone through, from undergraduates to the most senior people in the room, have gone through different stages where they have built upon the progress of what they learned, but also they learn from others. And so here, I want to linger more on this slide than any of the science slides. This picture on the left is one of my favorite. It's me working with a couple of students, again, on one of the parabolic airplane flights to do an experiment. Again, probably looking at dirt and microgravity, but we have these two students that were flying with us on this flight. The picture on the top is all of us in front of the plane, very excited about the opportunity to do these kinds of experiments. So one of the things that's really important for me is really developing the sense of community, mentoring others. And I know that this award speaks to that. And so I think that one of the things that I respect about this conference and that brings me back every year is this amazing sense of community that we have as scientists and engineers. And it's a really unique community because it is driven by exploration. Most of the people here in this room are driven by this desire to explore other planets, whether in person or with their instrument of choice. But this desire to explore other planets and really get to understand what's out there and what we can know about these surfaces that are all around us. And so my development through this community has been a long one. I actually started, as I mentioned earlier, my first experience at this conference was as a graduate student. And it's been amazing to see how the community has developed and how it's changed, and just how much support has always been given to the next generation and to the graduate students and to the undergraduates who are part of this community. If you look around right now, go ahead. There's a large proportion of younger people, undergraduate, graduate students, postdocs in this room, right? That's a pretty unique aspect of this community, is that there are so many of this next generation who are here and who are present. And maybe it's just because it's early and they feel like they have to attend and some other people didn't. But if you look around throughout the rest of the week, this will be true as well, right? There are posters, there are talks given by undergraduates and graduate students. If we go to the next slide, there is Loon Grad Con, which I was a co-founder of. It was a brainchild of Mihai and Andrew Poppy and myself, and it's continuing to bring in new scientists to the very beginning of the conference where they can get to know each other before they're here for the rest of the week in front of all of us scary professors, et cetera. And so it's really this awesome chance to get to know the community of your peers and your colleagues that you'll probably end up working with through the rest of your career, right? This is a great community, and the people you meet here this week, if you're grad students, if you're undergraduate students, are likely going to be the people you know throughout the rest of your career. You'll notice a lot of the people who came up on stage earlier have a history together, right? They've been involved in this lunar science or asteroid science community for a really long time. And that is what you have the potential to do, is to be that next generation, to continue on this legacy of a community of planetary scientists and exploration scientists. You'll notice some of the people in this picture are here today. So this is from Loon Grad Con in 2010. It was the very first Loon Grad Con. It was back when it was still the Lunar Science Institute and the Lunar Science Forum. Loon Grad Con, the name has stuck around. It's also welcoming to small bodies, though now it's not purely the moon. But it's really a great chance to get to know other colleagues. And some of the people here in this photo are also professors now or research scientists around the country. Some people have gone on to different fields. Some people study Mars, but we don't hold that against them. And some people actually study astrophysics, like Jack and some of the other people, and Rich and some of the other people here in this room, which is pretty unique and amazing. And so, how much time do I have left? I don't know, 2-ish minutes? Okay. So again, one of the most unique aspects I think about this conference and this community is its sense of community and its development from young students all the way up. If we go out later tonight, you'll probably go to Tide House or one of the other restaurants in town. And that wasn't an endorsement, by the way. And you'll be able to have dinner or have a soda or a beer with anyone here in this room. And it's a very, very friendly and supportive community. And I think that that's important, and it's important to continue that as we go along and to bring that to other meetings you go to and other parts of your career. And finally, I do have one last thing. As I was preparing this talk the last week, this paper came out that was sort of discouraging. There's a lot that's being done these days on studies of gender and roles in planetary science and in the community. And if you can go to the next slide, there was this paper that came out about double bias. So that has to do with the fact that women of color face greater risks of gendered and racial harassment. So we as a community, as I've been saying, are amazingly supportive. We support the next generation of students no matter where they come from. But as a community, we also have an amazing opportunity to start to address some of the issues that face the community in terms of gender bias and harassment. And I think that this community can really lead the way because it is so cohesive and so friendly. The title of this is upsetting, and it's based on data. It was actually published in JGR Planets, which I think is remarkable and speaks a lot to the advancement in this field. And if you go to the next slide, I just want to leave this up because it's from the paper. It's one of the final paragraphs of the paper. And it's speaking to the fact that if we, as a community, work together and address all of the science problems, but also all of the problems that sort of come as part of society, that we bring in as humans to this community, then we can really, really improve the community and bring new ideas and creative solutions that maybe haven't been thought of before. If you're a scientist who uses a microscope in the lab, you can find a solution to a problem. But you can't find a bigger solution until you talk to somebody who's studied LoLa data from the moon, and you can really build this cohesive picture of what's going on. It takes different viewpoints to make a better picture of what science is and what it can be. And I think that this community especially has a great opportunity to lead the way in that and to work together to accomplish amazing science and exploration goals. And everyone is excited by space and exploration and science. And so it gives us that extra step and that extra incentive to be like, yes, anyone can participate and everyone should participate. And that's what we are as a community. So thank you.